think what I need to do actually, Simon, is to put a much higher powered resistor in there. Because the neon seems to be absorbing the charge fine, it's just frying the resistor now instead of the transistor. Which is giving us some really weird readings.
Yes. It's a case of you fry either one or the other.
That's right. Now the voltage is actually dropping now as that resistor is heating up. So that resistor is obviously changing its state and breaking down.
So it might be a good opportunity to, can you just...
And there's absolutely no voltage now coming out of G.
Is that because the resistor's gone now?
Yes, it's fried.
Yeah.
What I need to do is to find some better, higher powered resistors.
Can we just talk about how the transistor was fried on the your big machine, Tom? Can you
what I was trying to do was
I'll just show it there, it's in the corner.
Yeah, it's in the corner in the scrappy. What I was trying to do was to feed some of the charge back from the machine back into the primary battery to give us to try to recharge the primary or driving battery. I tried several ways, and the way I thought would work was by rectifying the charge by putting a diode in the line, and so therefore just feeding back positive charge instead of positive and possibly negative. But it seemed to take it for a few seconds, but then the transistor just literally fried. So that one's out of commission at the minute, but we're in for a redesign on it. We haven't given up, we're just changing track, I think.
So a work in progress.
Absolutely.
And the last thing I think, just to mention for this week, let's have a look at two 12-volt car batteries here. Just want to remind us what's happening with these batteries. Sam, can you remember the voltages off the top of your head?
On the bigger grey battery, the highest voltage we could get conventionally was 10.1 volts.
The dog's Tyson, folks. Yeah. And to say hello to people, Tyson. Oh, there he goes. Yeah.
The highest we could get, the highest charge that would hold was 10.1 volts. We've charged it a couple of times, or rather we've charged it for a couple of sessions, if you like, various Bedini machines that we've built. This one, the fan motor, and also that Mark II. And over the period of time, although we've only given it bursts, we know that it will hold something around 12 volts. So the health of that is improving every time we charge and discharge.
Just remind us, what was it originally?
It was 10.1, that's the maximum we could hold.
So we got it up to 12.
And we got it to 12. What we've got now, we've got a series of just bulbs connected to these batteries.
Yeah.
And we're trying to discharge the batteries. As you can see, there are three live bases connected to it. We're trying to discharge the battery down to as low as we dare, really, and then give them another charge with the Bedini and see if the health improved any more. But after saying that, these were totally dead batteries, and these lights have been running now for days and days on and off, and we still can't discharge them. So
we're having a bit of problem discharging the batteries, but we want to discharge them so we can charge them up again, because
we believe that the secret to conditioning the batteries is to discharge and recharge and discharge and recharge with the Bedini, and get the batteries conditioned, if you like, to take in radiant energy as opposed to conventional.
And one thing that we've got to be on the lookout for in the future is this sort of coolness, because we believe the radiant energy as it comes in is cooling stuff down.
Yeah.
And the other thing that we'll be looking for, a nice little trick that I mentioned to you, I've seen on one of John Bedini's DVDs, is where he takes the end of a lead of a light bulb, connects it to just the plastic case of the battery, and then puts the lead on the ground, and the bulb lights up, something that you can contemplate with a conventional battery. So that's something we'll be looking forward to as well.
Yeah.
Anything else on this one?
Not really, other than quite a lot of surprise and confusion, really, as to exactly what it is we're seeing on the oscilloscope. As we said, on various machines, we've found voltage outputs ranging from, when we take a conventional reading, we might get something in the region of 12 to 15 volts coming out of the machine. But then when we put the scope on there, we've recorded 150 volts, 300 volts, and even with the fan machine, I think we recorded something like 600 volts. So, but you can't pick that up with the conventional meter. So I think it's very strange. I'm not sure what we're seeing. We're not sure whether it's pulsed DC, whether it's an AC charge, or whether it's just a radiant spike. So we've yet to discover what that is exactly.
So we're still learning?
Yeah, absolutely. Very, very much so. I don't think we've scratched the surface yet. You can see now we're showing about 125 volts coming out of there. And I'm just wondering what the conventional readings would be.
Yeah, and we've got an IV resistor there, haven't we?
Yeah, we put a big old
And we're
power
not connecting
resistor.
to the battery.
Not at all, no. We're just feeding straight into the oscilloscope lead.
So, in our personal understanding, we've been discussing, is that the radiant spike or the DC pulse or both? And I just wanted to tag this onto what we filmed before just to show that we're actually getting that. Okay.
This is what's going.